Okay, so in 7.3 you started trying to see a connection between the A and the effect it has on some graphs. So we're just going to look at three types: a monomial, or actually a linear, a quadratic, and a cubic one, and see what just A has. And we'll look at it in its easiest forms. So what you should have noticed is that as A approaches infinity, that means as A gets bigger and bigger, the graph ends up stretching taller. So it stretches taller. And I'll say taller kind of in quotes here. Okay? So the graph is going to get narrower and narrower is what it's going to appear to. This part right here that says as A approaches infinity, you can think of that as A gets bigger. Okay? So as it gets bigger, there. So what I'd like you to do right now on your graphing calculator is go ahead and type in y equals x, y equals 2x, y equals 3x, y equals 4x, and y equals 5x. Okay, so go ahead and type those into y1 through y5, and then graph them. And if you would graph them with a zoom 6, that'll make it a 10 by 10 graph. So go ahead and pause this and graph those, and then have those on your calculator. Okay, what you should have seen is something like this, where this one right here is y1. So we'll label that one and say that is y1. This one is y2. This one is y3. And then we also have y4, which is right here, and y5. Can you go ahead and copy those down on your paper? And you'll see that as we made the A get bigger, it appears that the linear is getting steeper and steeper. It appears like it's stretching taller. Okay? So make sure you've got that copied on your paper. Okay, as soon as that's copied on your paper, then the next one I'd like you to do, we're going to walk through the same thing with x squared. And we're just going to keep changing the leading coefficient, which is the A, and make it bigger and bigger. Okay, so I'd like you to go ahead and erase those other ones in your graphing calculator and type those into y1 through y5 and graph this with a zoom 6. And then as soon as you've done that, then copy it down on your paper, and it should look something like this, where this outside one is y1, and then they work their way in all the way to y5 is the narrowest one. So you saw the same thing where it appears that it's making it stretch taller. It appears like it's getting narrower. Okay, last one I want us to try for this is, let's do the cubic ones, x to the third, 2x to the third, 3x to the third, and so forth. Okay, and once you have these typed in, once again, go ahead and graph it with zoom 6. And as soon as you have it graphed, go ahead and pause this until you have it graphed. Okay, once you have it graphed on your graphing calculator, it should look like this, where this one is y1 and the very inside one is y5. So you can see that that is getting narrower and narrower also. Okay, so the big idea, if we go back to the very first slide we started with, was this right here, that as A gets bigger, the graph stretches or gets taller. Okay? All right, so we looked at a few examples there. Let's look at one other thing. What happens if A is negative? Well, then we're just going to, for right now, say the graph flips. And I'll put flips in quotes. Exactly what does that mean, flips? Well, let's start out by graphing a linear y equals x, and then also put in y equals negative x. So you've got that in y1 and y2. Go ahead and delete 3, 4, and 5. We only need these two. And then go ahead and hit zoom 6. And pause this until you have that done. Okay, so on your calculator right now, it should look like this, where this graph is y1, and this one is y2, and you can see it's flipped. It's done a kind of like a reflection almost. Okay, let's try another one. That's in y1, can you put x squared? In y2, can you put negative x squared? So now we'll do the quadratic one of degree 2. Go ahead and graph those. And again, graph those with zoom 6. Pause this until you have those graphed. Okay, on your graphing calculator, it should look like this. Make sure you're copying that down. This one is y1, and this one down here is y2. Again, it looks like it just flipped from up here down to here. It looks like it's called a reflection across this line right here, where it literally just folded down. Okay, let's do one last one here, and maybe you can even figure out what it's going to be here. Let's say y is x to the third, and y equals negative x to the third. And go ahead and graph that with a zoom 6. Okay, once you've got that graphed, this is what it should look like. Now, it looks just like the other one we did, except I've got different colors here. If you look closely, this is y1, and this is y2. So it's not two parabolas. This is y1, this is y2. And again, it looks like it's flipped. Okay, well, with those notes, now you're ready to go on to the Act 2 activity for Learning Target 7.3.